All right, we talked about congruence, congruent, what was the thing called yesterday? Congruent, what, figures? Is that what I called it?
Yeah.
Anybody take notes?
Figures.
Congruent figures, okay. So we mainly talked about triangles, didn't we? Yeah, for the most part. Today, we're 100% just talking about triangles. And on your homework, you had some things that were not triangles, didn't you? Didn't you have four-sided figures, but you could still see which ones matched up and all that kind of stuff? But we're just going to get pretty heavy into triangles right now, okay? So these are all dealing with triangles. Let's put a triangle. Seems like I always put, seems like I always put acute triangles. Let's do an obtuse triangle this time. Okay. All right, let's label this. We'll just do it really easy, ABC. And we'll just go DEF. Lack of creativity, but that's okay. Makes it easy that way. So up to this point, how would I know if these triangles would be congruent to each other or not?
Just based on how they look, or maybe some markings.
Well, yeah, nothing's marked just yet, okay, but I will mark some stuff. Now, if I was able to pick it up and just put it right there on top of it, then they'd be congruent. Agreed? All right. So what does that mean? That means all the corresponding angles would what? Are equal to each other, and all the corresponding sides would be what? Equal to each other, okay? So if I said, I'll tell you what, I'm just going to mark them with arcs and tick marks, okay? So if I said that those two angles were equal to each other, and these two right here were equal, and these two right here were equal, is that enough right there to say those triangles are congruent? Is it?
Yeah.
Well, don't you need to know, like, the sides?
Huh. Do you? Watch this. Look. Are these two triangles congruent, ABC and this little tiny one? Why?
Because
That's right. So you said, listen to what you guys told me. Not everybody, but a lot of you guys told me that if I just knew that these three angles were equal to each other, then those triangles were congruent. But watch, I'm going to show you that that's not true. Because if I did this, look at that bottom left angle. Is that equal? Yeah. Is that bottom right angle equal? Is that top angle equal? Are those triangles congruent? No. So you need more, don't you? You need more than just the angles being equal to each other. Agreed?
Yeah.
What else do you need? The sides. You got to know the sides as well. So you got to know that this side is equal to this side. You got to know that this one is equal, or these two are equal, and you got to know that these two are equal. Now do you have enough information to say that these triangles are congruent? Yes, you do, okay? If all three angles and all three sides are equal, the corresponding ones.
Jackson Pepple to the office for dismissal, please.
Okay. So then these triangles are congruent. The thing we're going to learn today is you don't have to know all six of those things. You don't have to know all three sides equals all three sides, and all three angles equals all three angles. You don't have to know all six of those things, right? I'm going to show you how many, just two today. We're going to do some more the next lesson, okay? But for right now, we're just doing two. Okay, let's talk about this other word before I do that. These are called congruents, right? Because these triangles are going to be congruent to each other, but postulates. We've also used the word theorem in the past, haven't we? What's the difference between a postulate and a theorem?
Postulates can have, like, more proof to them, like they can be definitely proven.
A postulate?
Yeah. Or is it the other way around?
Could be the other way around. Anybody remember us talking about this? Which one has to be proven? A theorem has to be proven, okay? A postulate is what? What did I say? It's just accepted as fact, okay? We just accept it. We don't have to prove it, all right? because you probably can't prove it, but it's true, all right? So it's true, no matter what. So these, the ones we're going to do today are postulates. Tomorrow we're going to do things that look very close to what we're doing today, right? But those are going to be theorems, and we can prove those. These right here can't be proven. We just accept them as fact. Is that all right? Okay. The first one is this. I'll tell you what. Let me copy my two triangles so I don't have to redraw them again. All right, here's my two triangles again. Now, the first postulate tells you this. And I'm not even going to put the letters in here. Logan, you with me? Up here. So what if I knew that this angle, is that better?
Yeah.
Can you see now? Okay. What if this angle was equal to this angle? And what if this side was equal to this side? And what if this side was equal to this side? I should be able to figure out a way on this computer to show you why this is true. But again, it's a postulate. We're not really proving it. Okay, we're just telling you that this is true. This right here is all I need to know in order to say what about those two triangles? That they're congruent to each other. That's it. Okay, I don't have to know the other two angles. I don't have to know the other side. This is all I need to know in order to say that this triangle is congruent to this triangle. Because if you think about it, watch. You've got an angle, right? You got an angle right here. If I extend that a certain length and I extend that a certain length, is there any other way to make a triangle that looks different than this with that information? So let's do this. Watch. I'm going to ungroup it. I got to keep this length the same, okay? I can't change the length of it. So what if I moved it like that? I didn't change the length of it, but there's no way I can get a triangle out of that, right? If I go like this, then I'm going to have to move the other one, then they're definitely not going to be congruent to each other, all right? Is there any way to get this angle and this angle being the same, this side and this side the same, this side and this side the same, and get a different looking triangle? There's not at all. I guess what I could have done is maybe I could have like cut out maybe, I don't know, have like I don't know what I could use, like a piece of wood or something like that, right? Cut out a really thin, right, to make a line out of it. Maybe a toothpick or something like that, I don't know. Had a long toothpick, had one right here, had one right here. Is there any way to manipulate those sides and get a different triangle in this? Well, somebody might say, well, let's put that side up here and that side down here. Let me think about that. You'd still have the same exact triangle, okay, because this would still have to match up. So anyway, I can't think of a really good way to show you why this is true, but it is a postulate. So what do? We just believe it's true, all right? And that's all I had to know. I didn't have to know anything about this side and this side. I didn't have to know anything about this angle and this angle. I didn't have to know anything about this one down the bottom, this angle, and this angle down the bottom here. That's all I needed to know. So all I needed to know was that we had a side, we had an angle, and we had another side. Okay? Now, look where that angle is, though. Is it just any angle? It's the angle that's between, or sometimes the book will say it's the included angle between those two sides. You see that? I didn't talk about this angle up here, did I? Or this angle down here. Which angle did I talk about? The one that's between the two sides. You got it? Okay? So I've got a side, I've got an angle, and I've got a side. This is that same side, this is that same angle, and this is that same side right here. So if they match up like this, right, and the angle is in between those two sides, which it is here and it is here, these triangles are congruent. Give me just one second. We have a name for this, and it is a postulate, and we have a name for that postulate. And it's a pretty easy name. We call it the side angle, what do you think? Side postulate, okay? We call it the side angle side postulate. For short, we can write it down. We don't have to write the word side angle side every time. But when we say it, all right, when we verbally say it, I want you to say side angle side. Everybody got it? But if we write it, what do you think a short way to write this would be? Yeah. But if I ask you, why are those triangles congruent? You're not going to tell me SAS. What are you going to tell me? Side angle side. But when we write it down, you can write it down SAS. Everybody got that? Okay. So you would say it, I'll put it in quotation marks. You say side angle side, but you write SAS. If you wanted to write side angle side, you could, but that would be a pain, wouldn't it? It'd be a lot easier writing side angle side. So anytime you have a side, an angle, and another side, and that angle is between those two sides, no matter what, you're going to get a triangle that's congruent to that triangle. Cameron, you had a question?
Yes, so just to be clear, for it to be true, the angle must be in between the two.
It has to be between those two sides. Exactly right. Let me do another triangle. I'm still going to do side angle side, but I want to do just a different triangle just to show you. Okay? Copy that, group it, then copy it, paste. Okay, here we go. All right, check this out. What if I said that this side was equal to this side, this angle up here was equal to this angle here, and this side was equal to this side? What do we know about the triangles? They're congruent to each other. That's right. So these two triangles are congruent to each other. And I'm going to ask you, what is the reason? Give me a reason why they're congruent to each other. What would you write down? That's right. If I asked you verbally, what would you tell me? Side angle side. Everybody got it? So side angle side. That's you talk to anybody that took geometry before and you say side angle side, they're, oh yeah, I remember talking about that. They may not remember anything they learned about it, but they're going to remember side angle side because we're going to say it so much. Right? We use that a lot. All right, so that's a really big time one. What if I did this? Let's get rid of a lot of that stuff. Okay, what if I did this? Let's do a different color. All right, what if I said this side was equal to this side was equal to this one, and then I said this angle is equal to that one. Are they congruent to each other? Why not? That's right. Because that angle that's given to be equal is not in between those two sides. Okay? Now, I'm putting myself on the spot. I should have been prepared for this. Actually, I've taught this so many times, I should definitely be prepared for it. But what if let's do this. Watch. I'm going to copy that. Well, I'm going to ungroup it first so I can just grab that leg, that side. I'm going to copy this. All right, so this side is the same as that. Would you agree? So watch this. Tell you what, let's make it a different color just so it pops a little bit. All right, make it yellow. But what if I did this? Put it like right here. And we'll go a little bit more. You see that? Would you agree that those two sides are still equal to each other? Okay? That's got one tick mark, that's got one tick mark. Because I copied and pasted it. All I did was just rotate it. Okay? I didn't make it longer or shorter, kept it the same length. But now look, I'll tell you what I should have done. Should have put it on the other triangle. Oh, come on. There we go. Okay, would you agree with that? Now look, did I change that angle? Watch what I'm going to do. I'm going to take that to there. That angle stayed the same, didn't it? Let's get rid of that. That turned into this. Now look at that. I still have two sides, right? This side's equal to this one's equal to this one, and that angle is still equal to that angle. Everybody see that? But are these triangles congruent to each other? No, they're a completely different shape, but they still have these two sides equal these two sides, this angle equals this angle. Do you see why this is not a congruent statement? There is no side, what? Side angle. Everybody see that? Because of that reason right there. All right, so there's no side-side angle. Where does the angle have to be? In between. We call it, what did I say? I said it like once or twice. Starts with an I. The included angle. Okay, that's the word they use in geometry books. They say that this angle right here would have to be the included angle, which means what? Between those two sides that are given. So I think that was pretty good. Came up with that on my own. I'd probably seen it before, but there you go. So that just shows you that you can still have side-side angle and those triangles not being congruent to each other. But can you do that with this? You can't, because you got to change, you'd have to change that side or this side, and you can't change that angle. There's no way I could take this and make a triangle that looks different than that. Only thing you could do is maybe just rotate it or something, okay? That's all you could do. But it would still be congruent. All right, everybody with me on that? All right. I'm just trying to get you to understand why you can't have this. Now, there's another reason. I hate to say this, but there's another reason why this is not a congruent statement. It's not a geometry reason. It's not a math reason. It's not even a real reason, but it's a way, for some reason, I can remember that this is not a congruent statement. Because if I wrote it the other way, you see it? Okay. At least one person saw it. If I write it the other way, it's probably not a way that we want to write a congruent statement. You know what I mean? Okay, now you're seeing it. All right. That's not really the reason why it doesn't work. Okay. It's not really the reason why it doesn't work. But it's a way that you can look at it and you're like, oh, wait a minute. I can't have that. Okay. So there's no angle side, if you get my drift. Okay, without me saying it. All right, you get the idea? So again, that has nothing to do with why it doesn't work or anything else like that. It's just a way that we can remember that, oh yeah, that's not one of them. All right? Okay, one more and we'll quit, okay? Let me grab these. I'll just keep these triangles again. This one and this one, copy them. Let's do one more postulate. Oops, I missed one, didn't I? Come on. I'll just copy this one. Okay, here we go. Two triangles again, but now I'm going to give you different information. So watch this. Instead of two sides and one angle, watch what I'm going to do. I'm going to give you two angles. That's one pair of angles. Here's another pair of angles. And I'm going to give you a side that's included. What does that mean to be included? It's between, right? It's between those two angles that they give you. So I've got two angles, and I got this side right here. Every single time you have that, if I have a triangle that has this angle equal to this one, this other one right here equal to this one, and the side in between them, okay, are equal to each other, that automatically locks this in so that this is congruent to this. I can't keep those angles and I can't keep that side the same and get a different triangle out of it. I just can't do it as much as I try. All right, so guess what's true about those two triangles? They're what? They're congruent to each other. What do you think the reason would be? The other one was side, angle, side. What do you think this one's going to be? You got it. It's angle, what? Side, angle. All right, this is angle, side, angle. All right, again, you say it, angle, side, angle. Angle, side, angle. But how would I write it down? Well, if I said, what is the reason for this? And you had to write it down on your homework or a quiz or a test, what would you write? Just ASA, all right? You wouldn't say it. Okay, you'd always say angle, side, angle. But you write it down ASA. Does it make sense? All right. Yeah, that's it. Let's take a look at your homework. Let's maybe get you started a little bit on it. 4-3. What did I give you? 115 and 20 to 23. That's what I have written down.
Attention, students and staff. We are down to the wire. It's that
1 to
nasty school,
15.
St. Mark's versus us. A school that is
20 to 23.
not folks that love Jesus like us versus the Red Lion Christian Academy.
Yeah.
Red line Christian.
So here is the final thing that we put out there. It's just a little incentive to you all to make sure that you're motivated to vote until 12 o'clock tonight.
I'm doing that.
That is number one. If we win, which we will, you all will have a dress down day, and I will pick a class, that means a class from the school, to have a pizza party on Mr. Osborne. I stole his wallet, and I've taken his credit card, and we will use that to the tilt. So you will have a free pizza party on Mr. Osborne.
Thanks.
The dress down day, a pizza party, and we will have the winning spirit going into the football game, which we know we're going to win anyway. But just know that there's a lot at stake here. We have not beat them in a whole lot of things, and this time we'll beat them not only in cheer, but also tomorrow in the football field.
Next week.
So, click on those
Not
little
tomorrow.
things. Let's get a ton. And let's make sure we win.
All right. All right. Could there be any more announcements today? I'm sure there could. All right. So let's just take a look at a couple of these. I'll get you started, okay? So I'll let you use the rest of the time to work on this, but I'll help you out a little bit on a couple of these. So let's jump down to like 7 to 15. 7's kind of easy. Let's take a look at number 8. Number 8's something that we didn't really talk about, but would be a good problem to do. So let's do number 8 together, all right? You can just put it at the top, and then you can start with number 1 later.
What was the homework?
Just add it down right there. 1 to 15, 20 to 23. Okay. So let me draw this thing. Oh, I could draw it like this. Let me angle it a little bit. Where do I? Oh, there it is. Transform. And let's go about like 20 degrees. There we go. All right, where did I put my pen? Put it back in my pocket. All right, so this is number 8. So I'm doing number 8 for you, okay? Isn't that nice of me?
Yes.
I thought it would be. All right, and here's what they give you. Now, how many triangles do I have here? I got 2, and they have something in common, don't they? They got this one side in common. Would you agree? All right, because they're attached right there. Okay, so this side on this triangle will equal what? This side on the other triangle. And I'm going to give you, I'll show you how we do this. Here's what they give you. They give you that this angle is equal to this angle, and they give you that this angle right here is equal to this angle right here. But that's all they give you. That's it. But there's something that we can figure out just by looking at this picture. We just talked about it.
Because they share the same side.
They share the same side. Exactly right. Okay, they share the same side. So here's how we show this. I just put 1 tick mark right there. That means this side on this triangle has 1 tick mark, and the same side is on this triangle, and it's got 1 tick mark. But I just put the 1 right there. You follow me on that? You're going to see that quite a bit. That's the first time you saw it, but you're going to see it a lot on different homework assignments. All right, so make sure that you understand that. Now, again, I got 2 triangles, right? I got 2 separate triangles. This is triangle 1. This is triangle 2. Everybody got that? What do I know about triangle 1? Well, I know I've got 1 arc, I got one tick mark, and I got two arcs, right? You with me? So I got an angle, I've got a what? A side, and I have another angle. So I have angle, side, angle over here, don't I? Do I have the same thing over here?
Yes.
Yeah. I got one angle with the one arc, I got the side with the one tick mark, and I got the other angle with the two arcs. So I have angle, side, angle over here. So what do I know about these two triangles? They're what? They're congruent. And give me the reason. Why are they congruent? No, don't say ASA. What do we say? Angle, side, angle. Okay? So the reason that they're congruent is because of angle, side, angle. Let's put some letters in here. Now, this is important too. Again, I haven't exactly got to this when we did the lessons, but watch very carefully. Everybody watching? Don't get started on the other ones. Watch me, because you're going to see this a lot. I promise you. That's why I picked something like this. Let's call angle or triangle 1. Let's not call it triangle 1. Let's call it something else. Okay? But this left triangle, let's move it up a little bit. And let's move this over. I just keep it there. It's fine. What can I name this triangle? You can use any of the three letters. It doesn't matter what order you put them in.
WZY.
Okay, WZY. All right, that's what Cameron wanted to call it. So I'm going to call it triangle WZY. Everybody see that? I could have called it WYZ. I could have called it ZWY, ZYW, Y, or I forget all my combinations already. But you could call it any of the combinations of W, Z, and Y. Agreed? So I could have had a bunch of people pick a bunch of different variations of this. But if I'm going to say it's congruent to the next triangle, these parts have to correspond with this part. So the W. So the W is right up here, right? Is right here. It's got the two arcs. Do you see it? On that number 1 triangle, that left triangle, W's got the two arcs. Which one has the two arcs on this triangle?
Y.
The Y. So what goes first? The Y has to go first, because the ones with two arcs have to match up. The W and the Y match up, don't they? All right. And then we went what? Z. Well, Z has no arcs on it. Which angle over here has no arcs?
X.
The X. So that's going to go next. Now, of course, you only have one other letter available to us, but let's just see if it corresponds. It's got to correspond to the Y. This Y on this bottom triangle just has one arc. Which angle has one arc over here? The W, so that has to be W. Everybody see that? So when it says write the congruent statement, you have to write it in the correct order. You can't just pick up any order. If you go WZY on this, you have to go YXW on the next one. The W and the Y have to match up. The Z and the X have to match up. And this Y and this W have to match up. Okay? See, about half of you interested in this. The other half, just kind of, your mind is going elsewhere. You got to watch, because I'm telling you, when I'm teaching this thing right now, I'm thinking of all the times that you're going to have to do this. You're going to have to do this many, many, many times. Not just on this particular lesson, not just on this particular chapter. You're going to have to do this on the next chapter, the next chapter, the next chapter. Okay? So this is a foundational thing that we do a lot. So get it down now, understand it now, because later on you'll be fine with this. All right? Now, they also ask you, it says write a valid congruent statement. Write a valid congruent statement. So there's my statement right there. And then it says, give me a reason. Okay, what would your reason be for this? Why are these triangles congruent to each other? You only got two choices. Which one is it going to be? Angle, side, angle. That's right. There's an angle, there's a side, there's an angle. Right here, there's an angle, there's a side, there's an angle. So what's my reason? I'll put it in parentheses. Angle, side, angle. Again, we only have two right now. We're going to have probably 5, I think. Maybe another one. I'm trying to think. Around 5 or 6, something like that. Different congruent statements. Everybody with me? We're only doing 2 today. These are postulates. The other ones we're going to do are what?
Theorem.
Are theorems, okay? So we don't prove these postulates, but you can prove a theorem, all right? But that's what you're going to do. Let me do one more. Because they ask you something here. They say, if these triangles are not congruent to each other, here's what it says. It says, state an additional side or angle that would enable the triangles to be congruent. So let me pick a problem that you have to do that for, okay? I'm helping you out, okay? So don't go to sleep on me. Don't ignore me, because I'm trying to help you here. So let's find one.
12.
Let's see, is 12, no, 12's already, oh, well, I'll tell you what, I'll give you a quick hint. I won't get as involved on this one as we did on the last one, but I will. Boom, boom, something like that. It's not going to be exactly. It's kind of the same as the other one. They tell you that this side is equal to this side, and they tell you this one is equal to that one. And that's all they tell you. Are these triangles congruent to each other? Well, I got one side equal one side, and I got this second side equaling that second side. What am I missing?
Your angles.
But am I? Where's the angle? Yeah, give me a, we've talked about this before. Anytime you have two lines that intersect each other, what's true about these angles?
Oh, yeah.
What are they called?
They're
Vertical angles. Very good. So check this out. Everybody watch. Everybody watching?
yeah.
So what you have to do is you got to look at it. This is the only thing they gave you. All right, but you got to look at it and say, oh yeah, I see something that's equal to each other. We did that on the thing with the sides, right? Because it was shared by both of them. This one right here, I have to look at it and say, oh yeah, that angle has got to be equal to that angle. Why? What's my reason? Because they're vertical angles, and vertical angles are always equal to each other. Anytime I have two lines that intersect each other, I have two sets, two pair, right, of vertical angles. Everybody see that? So that must be true. So now why are these triangles congruent to each other?
Because it's.
I got two reasons,
side
and they're
and
letters.
side.
That's it. It's side, angle, side. You got it? So that has a side, that has a side. This has an equal angle, and, well, both of them are equal angles, and these two sides are equal. So there's a side, there's an angle, and there's a side. And I got the same exact side, angle, side over here. So these are congruent to each other because of side, angle, side. It's not really what I was getting at. I want you to look at 13. Let's do 13. All right, so let me give you a triangle that looks like this. And then I'm going to copy and paste it. Now, let's look what they give us. Everybody watching this? Should be writing it down because I'm doing your homework. I've done 3 homeworks for you almost. The other one I did about half of it, all right? This one right here, they tell you that this angle is equal to this angle. And they tell you that this bottom side is equal to this bottom side. And they tell you that this side over here on the right is equal to this on the right. So at first glance, what must be, I'll tell you what, let's put the letters in here as well. This is F, G, H. This is J, K, L. This is J, K, L. All right. At first glance, it looks like they're congruent to each other. In fact, I actually copied and pasted them. So in reality, they are congruent to each other. But you can't just look at it and say, oh, they look like they're the same. That's not good geometry. You have to be able to show that they are the same. So I've got two sides and an angle, right? So it must be side, angle, side. Is that correct? Why not? Because the angle is not in between the two sides. If they would have told me angle H equals angle L, then would they be congruent? Yes. Right now, as it sits, are they congruent to each other? We can't say they are. Okay, we don't know that they are. All right, we can't say it. So the question says, here's where it gets a little tricky. The question says, if you cannot prove they're congruent, show me something that needs to be equal in order to make them congruent. And we kind of already answered that, didn't we? So watch. What needs to be equal in order for them to be congruent now?
Angle H and angle
That's right. Angle H, if angle H was equal to angle L, then would they be congruent to each other? Yes. Give me a reason why. No. Stop saying SAS.
side angle side.
Thank you. We say side angle side, okay? We verbally say side angle side. What do we write down? SAS. But when we say it, we say side angle side. Here we go. So look, if those were equal, if, that's a big if, all right? But that's what they want to know. They want to know if certain things are equal, then it's going to make it congruent. So if H and L were equal, then these would be equal or congruent because of what? Side angle side.
That's what the question was asking?
They're asking
We're
that.
supposed to write that?
Yep, they say, the question says exactly, it says, it says if they're congruent, tell me why. Side angle side or angle side angle, okay? That's the first part. And then it says write a valid congruent statement, right? And then give the postulate that justifies it. That's the side angle side stuff. But it says if not. Originally this was if not, correct? Because they were not congruent to each other before I put those yellow things in there. It says if not, state an additional side or angle. You follow me? That would enable these triangles to be proven congruent. So I did. I stated an additional angle, right? Now, I didn't know that that's equal to that, but if it was, then what would be true about the triangles? They would be congruent. You see what they're doing here? Yeah. All right. So they're saying right now, before those yellow ones were in there, those were not congruent. But if, right, big if, angle H was equal to angle L, then what would be true about those triangles? They would be congruent now, wouldn't they? If those two yellow ones were true. Now, I don't know if they are, but if they were, they would be congruent. What's another thing that I could say? If. What's another if? So that's what they give you originally right there. Okay? What's another if? If what? F, right. Yep, if FG, line segment, or side FG was equal to what? JK, that's right. So if I knew, now I don't know, but if I did know that this side was equal to this side, then would these triangles be congruent to each other? They would. Why? Side, angle, side. All right? Side, angle, side. So the first, if the H and the L, it's because of angle, side, angle. If these two sides were equal, it's because of side, angle, side. Side, angle, side. Does that make sense? So at first, if I didn't explain that to you, I know for sure, 100% sure, because it happens every year, students come back the next day, Mr. Hammer, I had no idea what they're talking about, this additional side and additional angle, what's going on? That's what's going on. Okay? There may be a couple more like that in there, one or two, I don't know, probably not a whole lot, but one or two in there like that. But I did one for you. I think that was what did I say that was? 13? Yep, so I did 13 for you. Okay?
When we had angle H congruent to angle L, we said that it was side angle side, but it could also be angle side angle.
Yes, it's exactly right. I didn't even see that. Yeah, we did say side, angle, side, didn't we? But you're exactly right. You could have said angle, side, angle if those two angles were equal to each other. That's right. Okay? Or you could have jumped up here, couldn't you? Well, actually, that wouldn't have made any difference, would it?
Yeah.
With just the red ones, right? Just knowing that G and K were equal, still not enough information. Well, it kind of is. You want to know why? I've talked way too much today, I know, and it's warm in here. Why is it so warm in here? It's usually cold in here. Let me get rid of these. Come on. There we go. There we go. Now watch this. If I was to say that angle G was equal to angle K, is that enough information to say that these triangles are congruent? At first glance, no, because look, I don't have any side angle side, do I? Do I have side angle side here? Nope. Do I have angle side angle? I got an angle angle and a side, but I don't have angle side angle. But check this out. Watch this real quick. Last thing. I promise. Last thing. Again, this is something we're going to talk about a little bit later. But look what I have now. I've got two angles of this triangle equaling two angles of this triangle. What do all three angles add up to be? What do all three of these angles add up to be? If I add these up, I'm going to get the same thing as if I added these up. You see that? So what must be true about angle H and angle L? They got to be equal as well, right? Because 180 minus this, 180 minus that, which are the same things, has got to equal the same thing. So technically, if I knew that this was equal to this, I could prove that the triangles are congruent, because that means these two angles would equal. And look, there's my angle side angle, there's my side angle side, there's my angle side angle from right here, right? There's a bunch of ways you could prove that these triangles are congruent. All right? So that's kind of interesting, isn't it? All right? We're going to be talking about that later on. That was kind of a little sneak preview, but we will talk about that a little bit later. All right. Sorry I talked the whole time, but you had nothing else to do, did you? Might as well sit and learn. All right. That's good.